Hi guys, welcome again to Mosdi Academy. Today we have another viewer request video that is asking us to prove that the derivative of Sinx equals to Cosx. Like I said, if you're new to our channel, you can subscribe and as well click the notification button. Or under the comment section, you can as well put in your questions there. You may be lucky I pick it, or you send me a mail directly to my mailbox. Many students nowadays are now sending a lot of questions, which I do attend to. Sometimes I pick some of them and share them online. And most of these questions I send directly to their mail. So I will be solving question and proving according to the owner of the question, fundamental knowledge, good explanation according to what you want, according to the content of the mail. That is what I'm trying to do now. So for you to be able to solve sin s equals to cos x, that is d by dx, that is the derivative, or the y over the s of sin s, which we all know is equals to cos x, he or she is asking, how do we come about that? And we should try as much as possible to simplify it in the simplest possible means. That I pray I would be able to do that in this short video. So let's start. Before we can actually solve this simple question, and the way I love to solve questions, nothing is simple, nothing is hard. We need to understand few things. The concept of limit is important. The first thing I'll talk about is how students should keep in mind that they should be able to know that the limit of a function, as please I have to adjust some of my writing stuff that I'll be able to write conveniently. Now, fine. I think I should be able to manage this right up. So now the first thing is the limit of sin s. Well, I think it's better. Manage it no matter how over x as x as the limit of x approaches 0 or x tends to 0 is always equals to 1. That is the first thing. Now for beginners, you can keep this in mind as a formula. Whenever you have this trigonometric function in this way, or in the opposite way, in the inverse form of it, that is this or this term, is always equals to 1. Another one you can also keep in mind, because I said I'm going to be using 2. The second one should be when you have cos x minus 1 over x as the limit of the same x approaches 0. This is equals to 0. So I hope you can see this. I believe you can see. So this is like the two basic formula we have to keep in mind. Then we should be able to prove from our first principle the derivative of x to be equal to 0. Let's do that. Required to prove is just to prove that d by dx, that is the same as the y by dx of sin x is the same thing as, now I want to apply the first principle, and that I want to do now. Now, if I'm doing the first principle, I believe you have studied before that when you want to do this, it means sin, I'm taking limit of h approaches 0, x plus h minus the initial function itself, sin x, all over h. So this is the first thing, which as h approaches 0. I have only used the definition of derivative, which I believe we all have studied. Now, having done this, the next thing I'm going to do now is that I'm going to substitute the limit, which is the next thing everybody think you can do. But if you substitute the limit, is 0 under, is 0 on top, because sin 0 is 0, 0 plus h, this is also 0, 0 over 0 will give you what you call indeterminate function, which we don't do. Now, to solve this, you have to now include your trigonometric identity. Now, what is the trigonometric identity? The trigonometric identity of sine, which I believe you have studied before, and if not, there is sine. So the trigonometric identity of sine A plus B, which I believe many of us knew, and if you don't know it, that is why I'm trying to actually show it for you guys to see. Now, it's the same thing as saying sine A cos B plus cos A then the sine of b. Well, I'm only using one page to solve this, so I should be careful how big I'm writing stuff. So now, in this case, now our a and b are x and h. So I'm just going to substitute this directly. And doing that, let's just find it up. This is equals to a, now it's now x, so it will be sine x cos h. I hope you are following that. I'm trying to be as simple as possible. Plus then cos s sine h. Remember, there is a minus here, minus sine x, everything divided by h. Remember, as limit of h approaches 0. So that is that about that. Now the next thing I'll do now is just to rearrange so that it will be favorable. Now how do I rearrange? This is it. Now this is what I'm going to do here about my rearranging. I'm going to move what is here to this so that I can have as limit of limit. You can write limit as lim. That is the way we write it. So doing this rearranging, I'm going to have sine x cos h minus, I'm moving this here so that I can factorize sine x. Then I have a plus here. You can see I'm not rushing. Plus cos x sine h. Everything here is over h. And I hope you can see that. So that is that. Then don't forget, always write as limit of h approaches 0 is important. It's a mathematical which we use. Now, the next thing I do here is just to make sure I factorize. So let me factorize this. I hope you can see. Now factorizing this one, this is what we are pointing. Now, this and this, you can see, is like putting this and this in brackets. Sine x is common. I'll continue. So I'm going to have something like saying sine s is common. Hope you can see. Open the bracket and factorizing this line. So sine s is outside the main cos h. Then there's a minus sign. I hope it is minus that is here when I'm doing this so that I don't make mistake. I don't think, okay, yeah, minus, this is 1. Then we close the bracket. Then I have plus cos s sine h, everything all over h. I'll still write the limit. I hope you can see. I'm trying to for you guys to see what I'm writing. So now the next thing now is now for me to finish up. And how do I finish up? Don't forget name as h approaches 0. Now remember the standard definition I gave to you to limit of s approaches 0 for this trigonometric function. This over this is 1 and this over this is 0. That is exactly what I'm going to do here. So if I try to rearrange this one, simply I'm saying sine x, open bracket, can you see, cos h minus 1 all over h, then plus, I hope you can see, cos x, there you have a sine h all over h. You can put all over here as h approaches 0. So now my dear students, it's just very simple now to just use the evaluation method to get the answer. So let's use the evaluation method. We know that when h tends to 0, cos h minus 1, look at it, cos f minus 1 over x, as f tends to 0 is equals to 0. So that means cos h minus 1 all over h here is 0. Is 0 times sine x gives you what? The limit here gives you is 0 plus, look at this guys, sine x over x as limit of x tends to 0 is 1. Look at this, sine h over h as limit of h tends to 0 will also be equals to 1. So you have plus cos x times 1. So cos x times 1 is 1. So now you have 0 plus cos s is nothing but cos s. So that means d by ds of sine x, that is the derivative of sine x, has been proved, and this is the final answer. So guys, this is all I want to do for today. Like I do say, if you find this video interesting, you can consider subscribing to Mostly Academy. And if you're a first-time person, and you want to actually send a question to me, you can send it to mostyacademy@gmail.com. You might be lucky your question is bring what I actually bring it out here to show on YouTube. But that being said, any question you send to me, I always make sure I will give a response to almost all of those questions directly. So guys, I will see you in my future video. Take care and don't forget, you always need to start by and what we need.